Hey everybody, this is Larry. This is day 25 of the Leetcode June Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's poem. Monday is actually a rest day for me for my exercise routine. A little bit, it's not actually a rest day, it's a rest running day. It's my usual strength training day where I do bench and squat. Today I just mostly kind of did recovery squats. I basically went same intensity, about 50% load, just to kind of hopefully help heal up the injury a little bit. I have a little bit of a shoulder thing. If you watch yesterday's video, I talk about it a little bit. Basically, I just fell awkwardly and then kind of have some. I think my shoulder's fine, but I have some mobility issues, so I was just working it out. So I didn't do any bench. I just did a lot of shoulder mobility, strengthening, and just try to make sure that it works okay. When you're old, you know you have to do these things. And I feel like there are just like 80 billion little exercises that you can do. So it's always kind of tricky to figure that out. One thing that I do want to talk about, and actually I was talking about this, I don't remember I talked about this last week, though I did mean to, is that I think we talk about the gym, we talk about running, we talk about, well, more importantly, Leetcode, right? And I think one thing that I would say a lot is that you have to challenge yourself. You have to deliberately challenge yourself. You have to find problems that are, not too hard, because if you're too hard, you're just banging your head against the wall. Just like, you're squatting a really heavy weight, you're not getting up, you're not benefiting from it, right? And if it's too easy, then you're not really challenging yourself. So you have to find that level of difficulty, and that difficulty is just, maybe you could do a sort of a binary search, or just, this is where also contests help, because then now you figure out your rating and you do a little bit harder than you can in a more, you have more time to do it and so forth. But I would also say, so that, that's standard-ish. Maybe, I don't know. I mean, I think sometimes things that are standard to me is not standard advice to everybody. But in any case, one thing that I would add to that, though, is that it's okay to have easy days, right? Like, if you, I think this is how people get burnt out in terms of getting streaks, right? And I have a video on streaks and kind of doing this. And yeah, so, maybe you don't need to do a hard problem every day, is what I mean, for example. Because it's just really tiring if you can spend 3 hours of full effort, 100% effort on like 2 hours a day. That's a lot, right? Like a hard effort. Like by the end of the week, you're just like, I can't see another problem. So definitely have easier days where you just work on easier problems, things that you should be able to solve way easy for you. And there is an analogy of this both in weight training and running, right? Like you should run easy days, because if you're running a marathon every day, I mean, some people, I guess, eventually get used to it, but if you run a marathon every day, your body will just break down and you can't really do anything, right? So you have to run like a much slower days and easier days. And same thing with weight training, right? Like once in a while, it's in the current literature that maybe, especially after the beginner steps, you should deload every month or so that your body can catch up to all the learning that it has to do. So, I mean, it's not quite like that, because there is some physiology thing, and learning isn't quite 100% like your muscle building. But still, in terms of pacing yourself, I think that is something that you need to figure out how to do. And also it helps, right? Because when you talk about contests, and when you talk about solving a hard problem, Q4 in a contest, well, it matters how fast you solve the easier ones as well, right? Because, if you have only half an hour to solve Q4 versus if you have an hour to solve Q4, then maybe the result will be different. Maybe not all the time, but sometimes, like if a problem you feel like you can solve in 40 minutes, but you only have 30 minutes, then you're just not getting it, right? And that's just how these things will work out. So definitely, and one thing that even on easy problems that you get to practice is on implementation and on speed, right? Like, that you're going to do it, that you're attempting a easy problem, try to do it as fast as you can. I think that's basically my goal to you. And I say this sometimes on different videos, because on some of the daily videos, you get it easy, and I'm like, okay, well, look, if you're doing this problem and you feel like this is, we've already done something similar yesterday or something, maybe not today because it looks like a tree thing, but especially on days where, or for daily problems where there's a sort of a theme, meaning like there's chunks of 3 or 4 days that are doing the same idea. Well, look, on day 3 or day 4, try to just do it as fast as you can, right? And use a timer, use a watch or whatever to measure yourself so that you're not lying to yourself, and then it just becomes then you can work on that speed and it becomes easier. And keeping in mind that you're not only getting faster when you work on getting faster on the easier problems, you don't only get faster on the easier problems, right? I mean, you do get faster on the easier problems, but those easier problems are often used as like building blocks and Legos in different components. Like if like some hard problems, especially on Codeforce and more problem solving things, requires basically you thinking to solve 3 or 4 different easier problems, right? Like together in chained kind of way. And if you're able to get some of these components in a faster way, then well, now you're working faster on your Q4 or a difficult problem, right? So that's basically the idea. Maybe I should do a video on this one, like one of my videos on my other channel. But nonetheless, that's all I have for this idea. So let me know in the comments what you think about that, and let's take a look at today's problem. Today we have 1038, binary search tree to greater sum tree. Given the root of a binary search tree BST, convert it to a greater tree such that every key of the original BST is changed to the original key plus the sum of all key greater than the original key in BST. Let's say it again. Convert it to a greater tree such that every key of the original binary search tree is converted to the original key plus the sum of all the keys greater than the original key in the binary search tree. Okay, so let's say we have this example 1, we have 4, but now we convert that to the sum of everything to the right, which is going to be 7 plus 8 plus 5 plus 6. Okay. Okay, I mean, I think the key thing is just I think we talk about the last couple of days if you've been watching, and hopefully you've been watching and not just watching this one, or maybe you skipped this one. I don't know how people do, but is that the thing that I talk about a lot is loop invariance, right? We've been doing sliding windows, we've been doing contribution problems, and one of the key parts of it is finding out these invariants, which means things that don't change for every loop. And in this case, with a binary tree or just tree structure in general, tree structure obviously is a very recursive structure because a tree node contains tree nodes and so forth, right? You can see by the definition, kind of, maybe not, okay, but in definition, right? And then the idea here is try to find this idea of recursive invariance, right? Like invariant that happens as you do a recursion. And that's basically what we're going to do. So do we update or do we create a new tree? Oh, apparently this is the same problem. Did we do that one? Okay. Why do we have the exact? They even have the same input. Are they that lazy? I did this. I was just checking to see if I did this one because then I would do it. Then I could get a free submit. Did I do this one too? I guess I did it this one too, so it doesn't matter. But yeah. And then here the idea is changing the nodes and then the values and so forth, right? So here maybe we can do maybe get sum or something like this, right? Get sum of node, which gets you the sum of the subtree starting with node as the root, right? So if node is none, we return 0. Otherwise, this is a very straightforward get sum, right? Then now it is going to be just let's just say left is equal to get sum node.left, right is equal to get sum node.right, and then we can just return left plus right plus node.value, right? Now, I mean, this is very standard get sum stuff, very recursive, very standard recursive things, and I don't say that to be like you have trouble with this. Definitely, there are a lot of problems to practice this part, maybe even this one. So yeah, and then the idea here is that we also want to update the node to contain all the keys greater than it. Are they unique? Okay, yeah, just want to make sure. And that just means that node.value, we added to everything to the right of that, and that should be good, right? Except for that now we updated node.value, and node.value is here, so we kind of just have to retain the previous node.value. And that really should be it, right? So then now, maybe get some is a terrible word, but then now we can return root. Hopefully I did that right. Nope. What did I get wrong? Oh, the 6 I do not add. And also the 30, where's the 33? 33 is, oh, I did mess this up. Okay. Well, talk so much about it, man. No, I messed this up because basically, yeah, I mean, yeah, I just got, and this is what happened. I'm just trying to think about how to explain it. I mean, this is a easy to fix, but the idea, the thing that I messed up is that my invariant was wrong, and this is what happens when your invariant is wrong. Is that I initially thought that my invariant is that for each node, I just have to do the sum of the right subtree, which is what I did here. And it made sense to a degree, and it makes sense for 4, and it made sense for 6, and then I just kind of got lazy with my induction, to be honest. That's what I thought my invariant was. But instead, what happens is that if you look at this example, well, 5 has to add 6, right? So that means that actually, it's not just the right subtree. On the left side, you want to actually propagate everything from the right side. So, pretty easy fix, really. And so basically now we have, say, I don't know, let's go with carry. I don't know if that's a good thing. But then right, and then here we do right, retain the previous value, add it to right, plus carry. And yeah, and that should be good, is what I want to say, but apparently it is still wrong. What am I missing? 30, I have 32, so I'm missing the 4. Oh, I'm missing the node.value, that's why, on the left side. Yeah, silly mistake. But that's basically it, right? Is that now we want to, the idea that we're able to get very quickly is just that, well, if you start from the right side first, then you could just carry everything to the left side. And that's basically the idea, is that I added a carry variable, and when no matter which side you come in, if there's something carry in, that means that, but the key observation, the key invariant here, the new invariant, if you will, new to me anyway, is that we basically, why did we change the order, right? That is critical as well. The reason why I changed the order is that that means that, and this requires a knowledge of traversals in general and binary search trees, which is that in an in-order traversal, it goes left, left root right? And of course that allows you in a binary search tree to get it in sorted order. But here we want to almost do like a prefix sum from the right. So then now we want to get the numbers in reverse order, which means that you do right, root, left, right? And that's basically the idea. We do right, technically I guess you can, you're gonna put this here for the node, but we don't really do much processing on the current node. And then left is just the same thing, right? It carries the carry, but of course the left side, we want to add the value as well of the current node, because that just keeps the invariant going. And that's basically the idea. Yeah. So what's the complexity for this one, right? It's going to be O of n times, because we look at each node at least once, and also at most once, so that, which is good. And in terms of space, this is going to be adverse O of h, which h is the height of the tree. It's a binary search tree, but not a balanced binary search tree, so it could still be a linkless binary search tree. But that h could be in the worst case linear of an, so that is going to be linear time, linear space. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.